It's good to see you guys. We're gonna start at 11:15. I just posted a link to Classroom, told them the lesson would start at 11:15. So you got a few minutes. Thank you for joining us as usual. How you doing, Jonathan? I have no idea how you got this link, but good to see you, buddy. We're gonna do some volume problems, Jonathan. I will share the document with you if you're bored and you want to do some math with us. Hi, Johnny. Good to see you. I will tell Miss Moran to send you more challenging work, but you're welcome to join us anytime. We're here at 11 a.m. And John A., for the days we have a Google document, at least right now, my plan is to use the YouTube thing for going through the lesson. It makes it a lot easier for me to be able to show my whiteboard at the same time as we show the screen and everything. If people are around, I do actually plan on opening up Zoom for half an hour or 45 minutes after we do lessons on YouTube on these days if you've got questions for Khan Academy, IXL, other stuff afterwards. So we're going to wait a couple more minutes. Once it's 11:15, we'll get started going through the first problem. Alright, one more minute and we'll get going. Alright, it's good to see you all. Thank you for those of us who are joining, and thank you to people who join us later and watch the recording. Quickly, before we get the lesson title away, the lesson today builds on what we were doing before with volume formulas. Our specific focus is going to be how do we apply these volume formulas to different word problems. The key terms, they're the same as they were the last couple days. The last thing I'm going to re-emphasize with these key terms, the radius measures halfway across the circle. The diameter is always twice as long as the radius. It's all the way across the circle. So it's a big thing to understand. Anytime they give me the diameter, I can go find the radius by just cutting the diameter in half. Some of the area formulas and the volume formulas that you're going to need are listed here on page 2. One thing I added for the circle, sometimes they ask us about the area of a circle, which is how much space the circle takes up. Other times they ask us about circumference, and circumference measures the distance all the way around a circle. So circumference has a different formula than area has when we're working through those circle-based problems. Here are the volume formulas that we have on our reference sheet. The 3 ones that we're most focused on, the 3 new shapes we're working with in 8th grade are at the bottom here. Those are the cylinder, the cone, and the sphere. We have the related formulas here you've worked with the last couple days. So hopefully, as we get to problem number 1 here, this is reviewing skills from the last couple days. They're going to ask you to identify what shape each one of these are for problem 1, the name of the shape, what formula you could use to find the volume for those shapes, and then finally what the volume is. I think in the interest of time, I'm just going to start working through that first problem. Feel free to identify in the chat for us what the name of that shape is and what the volume formula is. Once we identify the name of the shape and the volume formula, you can please also feel free to say, hey, this is what I got for the volume. So do we have anyone to identify what the name of this shape is here in purple? And also the formula that could be used for that shape. As Donald says, a bunch of other you probably, it's a cylinder. The tricky thing maybe here is that the cylinder is almost kicked sideways. It's resting on its side, but that's still a cylinder shape. So we're still going to use the formula for a cylinder, which is V, or volume, is equal to pi times radius squared times height. As with all of these formulas, the key once you identify the formula you need to use is what are the dimensions or the values for the different variables that I'm going to plug in. In this case, for our cylinder, since it's kicked sideways, hopefully you're identifying that the radius is 4 feet for this sideways cylinder and that the height of the cylinder is actually 12 feet. So once we identify, and I'll put this onto my whiteboard, the radius was 4 feet. That was the distance halfway across the circular base, and the height was 12. Then we can plug those numbers into the formula V equals pi r squared h. Once we substitute in, it becomes V equals, they told us for this problem to use 3.14 for pi, so I'm going to switch that over as well. 4 squared instead of r squared, and the height is 12 feet, so that becomes 12. At this point, if you've worked through this, feel free to identify for us in the chat what you ended up with for the correct or the final answer for the volume of this cylinder for number 1. 4 squared would give us 16. So this would become 16 times 12 times pi. (16 times 12 is going to give us 192. And when we take 192 and multiply that by 3.14, we end up with a final answer, or a volume here, of 602.88. This is measured again. If we take a look at that cylinder, it's measured in feet. So we're going to be square feet in that case. So final answer you should be arriving at for the volume of that cylinder is 602.88. Nope. And it's volume, so it should be cubic feet. That's my mistake. Anytime we're doing volume, they're in 3 dimensions. So you're always going to have cubic feet, cubic inches, cubic units, whatever it is. If there's no questions for that one, we're going to move on to the second part for number 1. the shape that we have for the second part, feel free to identify what's the name of the shape we're working with for the next one. What's the formula that helps us find the volume of that shape? And then ultimately what the volume is. The next shape is indeed a cone. Hopefully you are identifying for the cone. The volume formula is very similar to the cylinder, except there's a 1/3 as a coefficient. Because the cone caves in, it has 1/3 the volume of a same size cylinder. So our volume formula is 1/3 times pi times radius squared times height. So the big thing for us to identify, and this is lagging a little bit, I'm sorry about that, but the big thing for us to identify is what is the radius and what is the height for the cone. Hopefully you see this as an upside down cone, and as you're taking a look at the cone you would see that the height is 4 and the radius is 12. So into the formula would put 1/3 times pi times a radius of 12, which is going to get squared, times a height of 4. At that point we'd have to do the math out. Volume is going to be equal to all of these numbers multiplied together and the 12's getting squared. First thing I would do is square 12. 12 times 12 is 144. I also know that multiplying by 1/3 is the same thing as dividing by 3, so I'm actually going to switch this over to say divide this whole thing by 3. That's the same thing as multiplying by 1/3. And if I do 144 times 4, I get 576, which is still multiplied by pi and divided by 3. If I do 576 divided by 3, that gives me 192, so the volume is going to be equal to 192 multiplied with pi. We use 3.14 for pi. We end up getting the same answer, it turns out, that we had for the last problem. Different volume formula, a little different, 1/3 because the dimensions are related, they're just a little bit larger. We actually ended up with the same exact answer of 602.88. In this case they didn't identify whether it was in feet, whether it was in meters, so in those cases you can just say square or cubic units in this case. For our last shape that we need to work through, I'll put this whiteboard just a little bit larger for a second. So there's the work that got us to 602.88 for the cone. Now for our last problem we're going to shift over what shape do we have for the final one for number 1, and also what is the radius for this shape. As we've been working through these volume formulas, all of them seem to use the radius, not the diameter, so our question is going to be, for this shape, what is the radius that we're going to be working with? So again, feel free to identify in the chat for us what is the name of the shape for this last problem in number 1, and then also what is the radius? I do agree with Donald that the name of this shape that we're working with now is going to be a sphere. And what do we think the radius for this sphere is going to be? Because as we put that sphere formula down, make the whiteboard a little bit bigger. The volume formula for a sphere is determined entirely by the radius. It's v equals 4/3 multiplied with pi, which we're going to use 3.14 for pi, multiplied by radius raised to the third power. All three dimensions for a sphere are determined by the radius, so the volume formula only needs to know what the radius of the sphere is. I agree with Donald that the diameter for this sphere is 10 centimeters, which makes the radius half of that, or 5 centimeters. So we're going to need to take this 5 centimeters for the radius and plug that into our volume formula for the sphere. The volume formula becomes v equals 4/3 times pi times 5 cubed, or 5 raised to the third power. So then at that point, if v equals 4/3 times pi times 5 cubed, we'll just do the math out. 5 cubed is the first thing I would do. 5 times 5 is 25. And when I do 25 times the third copy of 5, 25 times 5, or 5/4, is worth $1.25, or 125 in this case. I have 4/3 and I have pi, so in this case what's going to happen, I would probably multiply my regular numbers together, the rational numbers first, 4/3 and 125, and then I'll multiply the irrational number pi at the end. So 125 times 4/3 is the same thing as doing 125 multiplied by 4 and divided by 3. That's what multiplying by the fraction 4/3 really means. And 125 times 4 is going to give us 500. And that's still going to have to multiply by pi. I'm going to put 3.14 in for pi because that's what we're using for pi at this point. So I'm going to do 500 divided by 3 multiplied by 3.14. And that gives me 523.33, and the 3 is repeating. In this case it's centimeters, so our volume is cubic centimeters. I think it's just you and me, Donald. Down to one person watching, it looks like. So that's how we get to the volume for the sphere on that final problem there. We're going to move on to number 2, number 3, where the word problems will start. And hopefully that's just our intro that shows us how to find volumes of cylinder, cone, and sphere. That's primarily what Khan Academy is asking you about on the later assignments this week. So I think if you understand those first few pieces there, you should be in very good shape to work through most of Khan Academy. And that's awesome to see. Who is that? TSM Kanye X SSB. Anyways. So we're going to move on to problem 2. And for problem 2, they're giving us a can of Coca-Cola and they're asking us to find the volume for this shape, or the volume for the can of Coca-Cola. So Donald or Jefferson, and sorry to get that wrong, feel free, Donald Jefferson, to identify for number 2, how are we going to solve this problem? What shape are we working with? What's the volume formula? What are the key things I need to see as I'm trying to find the volume for this can of Coke? So what shape do we have here? what are the dimensions that we're going to be using for that shape's volume formula. If you even want to just say what answer you have for number 2, since it's just 2 of you, then I'll go ahead and do this out for the people who watch the recording after. Thank you, Jeff. Yep, the shape is a cylinder. The big question is, what is the height, what is the radius for that cylinder, because for every cylinder we're going to be using pi times radius squared times height. And in this case, the radius for this cylinder radius, diameter are related to each other. The radius is actually not going to be 6. The radius is going to be 3, because the 6 represents the diameter, and half of 6, or halfway across the circular base of that can, is going to be 3 centimeters. So 3 is our radius, which is going to be squared, and the height for that can of Coke is the 12 centimeters tall. So then at that point, we'll just do the math out. Since there's a little bit of a lag between the chat, I'm going to go ahead and show us pi times 3 squared gives us pi times 9 times 12. If we do 9 times 12, 10 times 12 would give us 120, so 9 times 12, 12 less, is going to give us 108. So if you do 108 times pi, or 108 times 3.14, you're going to get a volume, just double check, of 339.12, in this case, cubic centimeters. Yep, Donald, you're right, it's 108 pi. That's also the volume for this cube. Let me make that whiteboard larger. I should have done that in the beginning. So there's our whiteboard working through a height of 12 centimeters, a radius of 6 centimeters, a radius of 3 centimeters based on the diameter of 6 centimeters. And here's our work a little bit larger for those of you watching on the recording. You could pause there and take a look. So that's how Donald, a bunch of the rest of y'all get to 108 pi, and 108 pi becomes 339.12, which shows us why B is the correct answer for number 2. If you used an incorrect radius, maybe you said the radius is 6, that may produce a different answer. If you didn't use the formula correctly, maybe that's how you end up at A or C. So at that point, we're going to move on to problem number 3. Those of you who are with us for problem number 3, feel free to identify for us in the chat. What's the shape that we're working with for problem number 3? Whiteboard a bit smaller again for a sec. And any key information we need to identify about this shape other than its name as we try to find the volume for this shape. Number 3 is not multiple choice, it's open response. You're also going to see we're going to round our answer or estimate our answer at the end here to the nearest 100, and then just put that answer in for a short response or open answer here. I'm with Donald, I'm with Jeff, that the shape we're working with here is a sphere, a volleyball. Any of these circular balls that you work with in sports, they're all going to be sphere-shaped objects. So the volume formula for a sphere is V, or volume, is equal to 4/3, that's our coefficient, times pi, times r, or the radius cubed. Again, for the sphere, the radius covers the length, the width, the height, all 3 dimensions. As Donald has identified for us in the chat, and we'll make the whiteboard a little bit larger now, the diameter was 8 inches, and if the diameter for that sphere, that volleyball, was 8 inches, that makes the radius 4 inches. So the key value, or the key variable we need to plug in for r, is going to be the value 4 inches. Makes our formula V equals 4/3 times pi, multiplied by the radius, which is 4, raised to the 3rd power. The problem tells us that the volleyball weighs 10 ounces. The weight of the volleyball doesn't really matter for purposes of volume, how much space it takes up, so that's kind of distractor information. All you needed is a diameter of 8 inches, cut that in half to a radius of 4 inches. Now we'll go ahead and do that formula out. 4 cubed is the first thing I would do, handle that exponent. 4 times 4 is 16. 16 times 4 is 64. Hopefully some of you remember 4 cubed from when we worked with exponents. That's going to be multiplied with pi and multiplied with 4/3. Again, as usual, I choose to multiply the rational numbers, 64, together with 4/3, then I handle pi at the end. Multiplying by 4/3 means take the 64, multiply it by 4, then divide by 3. So 64 times 4 divided by 3 is going to give us a fraction 85.33 repeating. So instead, I'm going to write this as 256 over 3 multiplied with pi. And if we plug in 3.14 for pi, we use a calculator, we could do 256 divided by 3, and then that still needs to be multiplied by 3.14. That's what you see up here in my Google Calculator toolbar up there. As I do 256 divided by 3 and then multiply by 3.14, the value we're plugging in for pi, I get an answer of 267.94, and then a 6 keeps repeating. Jefferson's correct that the nearest hundredth would put us at 2 decimal places. They asked us here for this problem to estimate to the nearest hundredth. But if it's 267.946, 946 is actually a little closer to 950 than it is to 940. If you remember, we look at the digit after. This is bigger than 5, so we're going to round up actually to be exact. When we round off to the nearest hundredth, we're going to do 267.95. In this case, it's measured in inches, so our volume will be cubic inches, or inches with that little 3 for the exponent above it. That's our answer for number 3. I think in the interest, since you guys are not in class and we can't go through 4 or 5 or check in on that later, I am, for the purposes of this video and to help the few of you who are here, we're going to run through 4 and 5 together as well. But if you're at home at this point, I'd definitely encourage you, 4 and 5 are challenging problems. I'd encourage you to try to pause the video, take some time to work through it. But in the interest of time, we're going to go ahead and work through 4 and 5 pretty quickly here together. Make this whiteboard a little bit smaller. For number 4, the more challenging problems with volume, instead of giving you the other dimensions like radius and height and asking you to find the volume, the more challenging problems will provide you with volume and ask you to figure out what the other dimension, the other missing dimension, would have been to produce that volume. So it's still key to identify the correct formula, to identify the shape first off so we know the right formula. In this case, we're working with a can of SpaghettiOs. In any can of food, the shape that we're working with is a cylinder. So those of you with me, I think you are aware that this is a cylinder. I think you're also comfortable to know that the volume formula would be pi r squared h, or pi multiplied with radius squared multiplied with height. So that's the volume formula I'm going to write down for this cylinder, for this can of SpaghettiOs. I'm going to make the whiteboard a little bit larger. We see 2 key pieces of information. This time we know the volume, and the volume for that cylinder is 753.6 cubic centimeters. So I'm going to plug that volume, 753.6, in for V into this equation. We also know what the radius is. We know the radius is 4 centimeters for this cylinder. So pi is just 3.14. That's not a variable. It's just an irrational number. That's a constant symbol. R squared in this case is going to become 4 squared because that's what the radius is. And h is what we don't know. H, the height for the can of the SpaghettiOs, or the family size can of SpaghettiOs, is what they've asked us to determine here. So h remains, and now it's the only unknown, or the only variable in our equation. What's more challenging is this equation was better built. They're designed to determine volume. So when we find volume, we just multiply everything together. When we already know the volume, but we're trying to find an unknown over here like the radius or height, we got to peel the onion or isolate that variable by solving the equation. The first thing I would do to solve this equation, if they've told me to use 3.14 for pi, I'm going to replace pi with 3.14, and I'm also going to do 4 squared, which gives me 16. So the equation has now transformed or changed after I substitute to say 3.14 times 16 times h on the right side of the expression. Let's make that a little bit larger. So if h is over here, and I want to solve for h, I'm going to multiply 16 with 3.14 first. I think that's the easiest step to take, just not the only way to do this. That's going to give me 50.24, which still gets multiplied by the height and would have produced a volume of 753.6. Now, the peel the onion step I'm going to use in this case is going to be to divide both sides because h is multiplied with a coefficient of 50.24. I divide by that coefficient on both sides to cancel it out and isolate the h, or the height. This gives me a height. If I do 753.6, that's the volume. I divide by 50.24, which came from radius squared times pi. That means the height must have been 15. If I plug 15 in for height, 15 times 4 squared times 3.14 would give us a volume of 753.6. So that's how we determine, and I'm with Donald. I'm just seeing his chat now. Sorry, I was a little focused on my whiteboard. But I'm with Donald and anybody else who ends up with a height of 15 centimeters. And like I said, you could actually go plug that height back into the formula, and 15 times 16, because that's what 4 squared is, times 3.14 will produce the volume that we needed of 753.6. Again, these are certainly the ones that are a little more challenging. It's really not till the end for Khan Academy that I think you start running into problems like this. Same thing for IXL. Awesome. Good to hear, Jefferson. So for the last one, and again, if you're at home, I would encourage you to pause this to take some time. Number 5 is a challenge, but it's something that you could be prepared to do. So I'd encourage you, if you're watching the recording, to pause it at this point. Try to work through number 5 on your own before you see us do this one out. So for this problem, I think one important thing is you read through to identify. First off is, of course, the shape that we're working with. And hopefully you see why they call an ice cream cone an ice cream cone. It is in the shape of a cone. So the volume formula we're going to be working with here is the volume formula for a cone. Make that whiteboard a little larger again, which is V equals 1/3 times pi times radius squared times height. As we read through this problem, I'll go ahead and highlight the question, which is a little tricky itself. It says, what is the circumference for the cone's circular base? So every cone has a circular base. A circumference, we're going to scroll up for a second. If we talk about circles, if we go back to our formulas up here, our reference sheet, for a circle, circumference measures the distance all the way around the outside of the circle, and to know circumference, you do pi times diameter. It's a simple formula for circumference, but you need to know the diameter to use that formula. Oh, sorry, that's blocking it. Let me restate that. So now that you can see the circle that I'm referencing, the circumference formula for a circle is pi multiplied by diameter, and we know if we know radius, we can just double that to get diameter. So in order to determine circumference for any circle, I need to first know its radius or its diameter. In this case, if they've given me a cone, and they've told me the volume for that cone, I could use the volume formula for a cone to potentially determine its radius. And once I know the cone's circular base radius, I could then use radius to find circumference. So the first thing I'm going to do is start using this formula and plug in. We know that it has a volume of 212 226.08 cubic inches. So it's not shown on the picture. You need to read and see the volume. In this case is going to be 226 and 800ths. That volume is going to be equal to 1/3 multiplied with pi multiplied by the radius squared multiplied by the height. We don't know the radius yet. If we did know the radius, we'd be able to find circumference, the main goal for this problem. But we do know that the height, based on the word problem, they tell us the height is 24 inches. That's a key piece I needed to pick up in the word problem. So our volume formula now only has, it's lengthy, a little complicated with an irrational number and pi with a fraction in 1/3. But r squared represents, r is the only variable we could solve for the radius now. To solve for that radius, I'm going to first want to isolate r squared. I want to get everything else that's on the right side of this equation, the right side of this river. I want to get rid of it. So I'm going to first multiply 24 times by 1/3. If you recall, multiplying by 1/3 is the same thing as dividing by 3. And I know that 24 divided by 3, or 24 times 1/3, is going to give me 8. So it becomes 8 times 3.14 times radius squared. When I did 24 times 1/3, that gave me 8. I switched pi over to 3.14. Make this whiteboard a little larger as we're working through here for radius of the cone. And now 8 times 3.14, because before division, before peeling the onion, I want to simplify the right side of that equation. 8 times 3.14 gives us 25.12. That's multiplied with r squared and equal to 226.08. At that point, to get r squared alone, we're going to divide. That's the opposite of multiplying. If the coefficient is 25.12, we divide by 25.12. Same thing on both sides to keep the scale balanced. So I need to figure out what 226, and totally okay to use a calculator, what 226.08 divided by 25.12 gives us. That gives us 9, and that's equal to r squared. So at this point, I know we've done a lot of work, take a breath. At this point, r squared is equal to 9, and I could take a square root from both sides if I didn't know at this point that r was equal to 3, because 3 squared is what would give us 9, so the radius must have been 3. So again, if I could square root both sides, that gives us just r is equal to 3, so we know the radius is 3. And if the radius is 3, then we can use that to find our circumference. It looks like Donald's already correctly gotten there, so the radius is 3. It's our last problem, so I'm going to erase some of the formulas over here to use some more room on the whiteboard. And if the radius is 3, circumference is equal to pi multiplied by diameter. And if the radius is 3 for this cone, then the diameter must be 6, because diameter is always twice as big as radius. So to find the circumference, pi times diameter becomes pi times 6. And if I do 6 times 3.14, I get 18.84. If I had done 6 times pi, Donald, I would get 18.85. I think your 18.85 comes from using the exact number for pi at 3.141592. And when we use only 3.14 as the estimate, that's why we end up just slightly smaller than you at 18.84. So that's how ultimately we arrive at a circumference for this cone's circular base. The circumference is going to be 18.84 inches. Again, that's an estimate If you'd use pi, the exact pi, you might get 18.85. That's totally fine to have in that case. We're using 3.14 as our estimate for pi. So that always makes our answer a little bit smaller than using the more lengthy pi that the Google calculator or other calculators use sometimes. So that brings us to the end of the lesson. Again, I would stress that number 4 and number 5 were challenge problems to make you think a bit today. A lot of the IXL and Khan Academy work is based on applying these formulas and some of the stuff we saw in problems 1 through 3. So thank you to those of you who joined us. Is there anybody who needs help on Khan Academy on IXL who would benefit from us going on to Zoom right now? I know we've only got 4 or 5 people with us. So if there is anybody who wants help on Zoom, I'm happy to log on there. But if not, if you think you're in good shape, I'm going to go ahead and just sign out myself and post the video on YouTube for other people to watch after. Alright, yep, Donald, and definitely your Khan Academy looks very good, Donald, so I'm sure you're in good shape there. Donald, thank you as always for joining us. Jefferson, thank you. Anybody else who's quietly here with us, thank you for joining us. I will see you tomorrow for our last Google Classroom lesson of the week on Thursday. Thank you again for joining us.